Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rahmat bin Mahiri and my friend is uh, today we want to explain about the smart phototherapy adjustable device using ESP32. Okay, we go through for the background project. So, phototherapy is the commonly used treatment for newborn babies using light source such as the LED blue to reduce bilirubin level in infants. There are many phototherapy devices in this country. Therefore, we need to make sure all the phototherapy in a good condition by using ESP32 with Arduino motor, and we can make sure that the phototherapy device can be used usually, and we also can insert the data at the website to make sure all of patients in the observation. So, for this objective of this project is to measure the suitable distance between a baby and LED blue using linear actuator and ultrasound. Second, this objective is change the distance using blink that user do not go to the baby for measure the distance. And the last objective is to monitor duration time in phototherapy process. For the problem statement, firstly, we need to manage the distance frequently. Second, the user must need to another supply for linear actuator. And the last thing is the need about or casing to place all about ESP32 and wiring. So for the scope and limitation, the light on maintain in range 1 until 12 hours only because we just use power bank for the Arduino. For the sorry, because we just use a power bank for ESP32. Second, range distance between lamp and baby in 30 until 75 centimeter, depend on size of baby. And the holder and only can hold the blue, LED blue and ultrasound sensor. And the last limitation is LED blue at the side of baby is fixed 50% of the main LED. So this is the hardware and software we use for this project. For the first hardware, we use ESP32 ambient light sensor for calibrate and for detect the irradiance. But ambient light sensor just detect the lux and we do the calculation and the program for convert to irradiance. Ultrasound sensor we use for the distance. Push button to change the distance. Liquid crystal display LCD to show the display output. LED blue for the is the main of the this project, and the linear actuator for the distance. So, so for the software we use three software that is the Arduino for the program, Blink uh for the distance and data we can get from the project, and Autodesk Inventor for the design of this project. So this is the block diagram of this project, Shafiq.
Yeah, this block diagram. This first section is for input. This is the input we use for linear actuator, and linear actuator will give has have a distant motion, different motion. So it will give a distance and provide a time. So next input is a light sensor. So light sensor convert to irradiance level. So and we go to process. This input will go to process, which is will programmable in ESP32. And ESP32 will looping for the DC motor for change of the height of the linear tutor. So we'll have a loop. So for the process, the output will have a LCD display for monitor at the project, and IoT platform also for monitor and can control it. Okay, next. This is our flow chart start. First step is for input is ultrasonic sensor detect distance. So for after the detect distance, link go to the linear actuator the change of linear to motor impact for to make sure they adjust for linear to motor distance length maybe will give two which mean ambient light sensor will detect irradiant value. So it will show the irradiant value. In the same time, for the ultrasonic sensor will show distant value. Next, for the output, first we go for LCD, add project, and next is IoT, blink and show information. So it will go look for at the start again because inside the void loop, so it will keep repeating. So and okay, this is result analysis for personic sensor. So actually, we use a measuring tape to compare with measuring sensor is personic sensor. We have a slight different, not too much, but around uh, below 10% because for the reading 43 for measuring tape and the sensor provide 45 cm. So this is actual chart comparison. Okay, this is our picture that measure for measuring tape and measuring tape from baby to lamb. Okay, next is the result analysis and light sensor. Irradiance in microwatt per centimeter square. So comparison is actual value is from radiometer and measure value from ambient sensor. So it fixed both both comparison will have same distance. If for 40 cm, actual value for radiometer is 800, 16 and 16.0 but measure value is 800 to 22.92. So we have a slightly different, not too much, below 10%. So for the precise and accuracy, I think for this sensor have a good accuracy because not above 10%. So this is our picture for test the radiometer and ambient sensor for comparison. Okay, this is our flow. This is the project. Second picture is when we turn on. Next is the calculation. Irradiance calculation because of ambient light sensor only provide lux. So for lux, we need to convert to irradiance. So one lux equal to 0.079 watt per meter square. But to change microwatt per centimeter square, lux to mass time 0.0079 divided by 10k, 10k and times 1 mega. 10k and 1 mega is to change from meter per square to centimeter per square and we want to the in SI unit micro. So we need to change then we need to put divide by 10k times 1 mega. So this is our calculation for irradiance. This is for coding software. We use Blink. This is our interface. The above is the chart. So we did appear the every time in output we get. So have a gauge and value. So control we have a up and down. So when we push up, so the denominator will go up. Down will go to down. So this is coding. So coding, we use Blink. So this has a Blink template, and we get all the uh, sensor coding. This is variable that we need to declare, but to state forward, relay button, and this is voice setup. So we need to declare as which is output and input. So we have a trigger pin and output pin is ultrasonic. Forward and backward is for involve relay. Button is for button up and down. Void data I said this function is for push button. So all push button if else conditional in here. So what is send distance is for ultrasonic sensor. So which means decoding for calculation for distance. So void sense sensor, we call for the distance value. So it will appear in sense sensor. So all the data will get print and appear output in LCD in this function. So all this function will call in void loop. So it is easier and so smooth and easy. So
For this is the project sketching of the solution of the project. So this is made by Shafiq with Autodesk and Inventor. So this is a diagram for this project. We can see that the sensor, ambient light sensor, placed between both of baby legs and ultrasound sensor at the main LED on the top. So we can see the box of ESP32 have a breadboard. LED driver have a 12 volt battery for the support for linear actuator. And LCD display we place at the front of the box of baby to make sure the user can see the data as well for make a decision. So the push button of linear actuator we place at the side of the box of casing to make sure the user can change the distance while observe the data on the LCD display. So we go to the more yeah. Okay. Next we go to the future work. In the future work, we want to add the automatically adjustment for this phototherapy project to make sure the user does not the manual adjustment for the change distance. And the second things we want to change for the future work is the baby blanket have a LED blue that can make the speed recovery for the baby. And this is the Gantt chart that is a plan and do we do from the January until May by me and Shafiq. Is the deeper analysis about our project and until submit a report, thesis, logbook and supervisor. So we will go through for the next video about a demonstration of our project. Thank you.
Okay, hi. This is our project for innovation. New innovation is smart phototherapy adjustable using ESP32. What innovation that we use is we use motor to adjust height from light from baby because hospital still normally using ruler to measure the distance for lamp and baby. So the dimension we use blink to control, which is can control up and down. So we can monitor also their data, which is can appear the distance value, irradiant value. So irradiant value to make sure the user can know how many or how long should be used for the baby for jaundice. So what the innovation? We used to use blink, but still have a manual button. This is for up and this is for down. And for this is LCD. LCD is for to monitor. And this is placement for baby. So the distance to measure is for this area. It's not detect for here, but detect here. That's all for the innovation.
Kan. Stop. Lagi. Stop.